Good morning students, how are you all? In the previous lecture, I have told you something about hydrogen and how hydrogen resemble in properties with alkali metal and halogens. Fine. Now today's lecture we will discuss that how the hydrogen is different with respect to alkali metal and with respect to halogen. That means we have kept hydrogen at the top of the periodic table because it shows lot of differences with respect to alkali metal and halogen. Let's see first of all with respect to alkali metal how hydrogen is different with respect to alkali metal. Let's see, first is non-metallic character. Hydrogen shows non-metallic character, that means it is a non-metal, whereas in first group elements all of them are metal. They shows the properties of metal like ductility, malleability, but in case of hydrogen it is behaving like a non-metal. That is first difference. Second is nature of compound. If we are talking about hydrogen, when hydrogen combines with oxygen it forms water, and in that case hydrogen forms कोवलेंट कंपाउंड. कोवलेंट कंपाउंड का मतलब जब वाटर फॉर्म होता है तो हाइड्रोजन ऑक्सीजन के साथ शेयरिंग करता है इलेक्ट्रॉन्स की. दैट मींस इट फॉर्म्स कोवलेंट कंपाउंड बाय शेयरिंग. वेयर एज इन केस ऑफ एल्कली मेटल, फॉर एग्जांपल इफ वी से सोडियम या पोटेशियम या रुबिडियम, दे ऑल कंबाइंस एंड फॉर्म्स आयोनिक कंपाउंड. आयोनिक का मतलब विच आर फॉर्म्ड बाय ट्रांसफर ऑफ इलेक्ट्रॉन्स फ्रॉम अ मेटल टू अ नॉन मेटल. इफ आई से सोडियम क्लोराइड, sodium loses electron whereas chlorine gains electron to form ionic compound. Whereas in case of the compounds formed by hydrogen, they are always covalent compound. They are formed by sharing of electrons. Fine. Next is atomicity. How hydrogen is different in case of atomicity with alkali metal. Hydrogen is diatomic in nature. It shows atomicity 2. That means it behaves as H2 molecule, whereas all the alkali metals are monoatomic. If we say sodium, it is monoatomic, single atom is present. Right. Next point, how it is different. Nature of oxide. If we say hydrogen, when combined with oxygen, they form neutral oxide. That means water is neutral. Whereas we know that metallic oxides are basic in nature. That means why it is basic? When it combines with water, they form water soluble base. That is why they are called alkali metal. In that case, we say hydrogen is different in case of with respect to alkali metal. Next, how it is different with respect to halogen. Let's see. First point is nature of oxide again. When hydrogen combines with oxygen, they form neutral oxide, that is water. Water is neutral. Whereas we know that non-metallic oxides are acidic in nature. Non-metallic oxides क्या होते हैं? Acidic होते हैं. That means they turn blue litmus to red. For example, this is an oxide of chlorine, Cl2O7. It is highly acidic in nature. Now see the next point, how it is different with respect to halogen. Second is less tendency to gain electron from hydride. All the non-metals we say, non-metals have a tendency to gain electron, especially in case of halogen like chlorine, fluorine, bromine. They have 7 electrons in their outermost shell. That means they are in great need of 1 electron to complete its outermost shell. That means they have a great tendency to gain electron. Whereas in case of hydrogen, they have very less tendency to gain electron to form H negative ion, that is hydride. Fine. Next point is absence of unshared pair of electron. This is a very important point. Hydrogen exists in the form of a diatomic molecule H2. Similarly, all the halogens also occur in the form of a diatomic molecule like F2, Cl2, Br2. When we are seeing the structure, this is electron dot structure of hydrogen molecule H2 and this is electron dot structure of Cl2. That means when we see the electron dot structure after sharing, there is no electron left over here. That means there is absence of unshared pair of electron in case of H2 molecule. Whereas if we see in case of Cl2 molecule, there is 6 electrons over here and 6 electrons over here. That means there are a lot of unshared pair of electrons in case of halogens. Whereas in case of hydrogen, there is absence of unshared pair of electron. Hence, we can say that hydrogen shows lot of difference with respect to alkali metal and with respect to halogens. Hence, there is no fixed position of hydrogen. It is kept at the top of the periodic table. Fine. Thank you. Now see the next topic, isotopes of hydrogen. This you have done in class 9th, that hydrogen exists in 3 isotopic form. What are isotopes? Isotopes are the atoms of same element which have same atomic number but mass numbers are different. Here we see there are 3 isotopes of hydrogen exists in nature. First is protium. It is represented as 1H1, that means mass is 1 and atomic number is 1. Next is deuterium. It is also called heavy hydrogen. Its symbol is 2H1, that means mass is 2, atomic number is 1. Third is tritium. It is 3H1, that means mass is 3, mass number is 3 and atomic number is 1. These are the three isotopes of hydrogen. Just see one by one. First is protium. It is represented as 1H1. It is the most abundant isotope of hydrogen that is present in this earth. It is near about 99.9% present all over. Whenever we are using hydrogen, we use this protium. It is represented by symbol H. Whenever we are using H, that means we are using protium. Fine. Now, it contains one proton and one electron. It does not contain neutron. That means it is only the isotope of hydrogen which does not have all the three subatomic particles. That means it does not have neutron. Next is deuterium. It is also called heavy hydrogen because it is present in heavy water that is used in nuclear reactors, and it is represented by symbol D. And heavy water symbol is D2O. Its formula is D2O. Fine. It has one proton, one electron and one neutron. Fine. Next is tritium. It is a rare isotope which is present very rare. It is, we can say, 10 to the power minus 15% in the earth. That means it is very rare isotope, and it, because of its instability, it is not stable, and it, because of its radioactive nature, we say it is very rare isotope. It contains one proton, one electron and two neutrons in it. Fine. And we can prepare this tritium by bombardment of neutrons with nitrogen atom. This is neutron. Neutron is n, small n. Is small n, that is representation of neutron. When it is when we are bombarding this neutron on nitrogen atom artificially, then it forms tritium, that is the third isotope of hydrogen. In that way, we can prepare tritium artificially. Hence, these are the three isotopes of hydrogen, that is protium, deuterium and tritium. Okay.